Thank you very much. Welcome to my session about the Raspberry Pi on .NET Core on Linux. It's a good pleasure to be here. I know usually my sessions are easier because the setup is not that complex. As you can see now here, we have the different devices. And just for your info, if you are curious to see the devices much closer, we can continue the conversation later on in the discussion zone. So please join on to see taking a closer look to the devices themselves. So, who am I? I am Raffaele. You may know me from previous edition of DotNext. I've been here in Russia several times. I have been in Novosibirsk and then Moscow and then St. Petersburg as well. And by the way, here you have a really wonderful city. I'm very happy to be here. And I am an independent consultant. I have several experience in different areas. It's quite incredible to see how many different perspectives I can see during my daily job with many different companies, and that's tricky. And it's also valuable for me to hear from you what are your opinion about .NET and so on. That's basically the, let's so-called, job for the MVPs. So as a Microsoft MVP, I enjoy exchanging ideas so that I can give feedback to Redmond in Microsoft when I go to the campus, and we discuss the new technologies, what's going on, what's better for the next version, and so on. So please make questions. The agenda for today is to introduce first few concepts. How many of you are already familiar with the hardware devices? Okay. That's extremely important to make some distinguish between microcontrollers and full computers, and I will start from there very briefly. Okay, I won't want to waste too much time about it, but just to clarify some points. Then we want to focus on .NET, of course. We want to see what is .NET Core on a device. What does it mean? Usually in the past we had .NET Core on Windows and nothing else. Now not only we have .NET Core on Linux, but even on a device that can control the IOs and communication ports and the physical devices and so on. And also, we will see in a very complex demo, let's see that there are many pieces inside the whole stuff, that we are really leveraging all the goodies that are inside the new versions. So I took the best from .NET Core 3.0, ASP.NET Core 3.0, which is a wonderful framework even for the IoT space, and we will see why. And so we are using already span of T, memory of T, pipelines, and so on, all the things that are the most advanced available inside the framework. And there are a few things that are extremely valuable also for you if you only work on desktop, because, I mean, for example, publishing the app is something that we all have to do. And the publishing, the number of publishing possibilities that we now have with .NET Core 3 are much greater, and we will see in detail what I mean. It's extremely astonishing to see how well can go those things. And there are a few things that when we come to the hardware, we are going to the deeper level, so a lower level, we are going to the metal, we are talking with the hardware, and so sometimes we need to talk with the C++ libraries. And one of the most complex is OpenCV. How many of you are already used OpenCV in the past? Okay, you may know that it's extremely difficult also just to compile the whole library. It's not straightforward. I mean, it takes a huge amount of RAM in compiling it. It takes a huge amount of time also to compile. And you can imagine that you cannot just compile on the Raspberry Pi. So how can you leverage the power without having the possibility to compile inside the device itself? And of course, code. So let's start. The first thing that I want to show, I have the actual device, by the way. So later on the discussion zone, if you want to see these things, we can take a look with a closer look. This is a very small device, which, by the way, is super powerful, even if it's so tiny. So you can imagine this is an USB port, and so the device is really, really small. There are smaller, of course. If I remember the old PIC microchip that has just 8 pins and have like 4 megahertz. This is 20 megahertz, so it's, I mean, more powerful than many other PC that I used in my life. So it's extremely powerful. And you have IOs at your fingertips, so you can use whatever you want to interface with other device. And the blue device that you can see here is a temperature device, which is a digital device. It's a one-wire communication channel, which is tricky. Because even if it's a very small device, just a temperature, it can give you temperature and humidity, DHT 11 or 22. This is extremely tricky because one wire means being extremely precise in the clock. So the communication must be extremely precise. And when you come to an operating system, you have a problem. So you have multitasking, you have multi-threading, you are being interrupted even if you don't want. Even if you take your thread and you say, I am priority 0, I want to run with the priority that is best on my machine, you cannot have precise timing, and so it's extremely difficult to make the communication work with such device. It's possible, definitely, okay, but you may end in having some communication error you have to recover, because from time to time, maybe there is the swap file that is coming. You have virtual memory, you have other interrupts that are coming. Instead, in this kind of the devices, you write software, and you are synchronous. There is no operating system. It's only your code that is going on. So this is the very first important difference between the two words. Then if you want to have more power, but again, without an operating system, you go to this kind of devices. By the way, this company is a Russian company, which I don't have anything with, but I discovered that it's based in Moscow. And it's an extremely powerful microcontroller, which has DMA. I mean, you can imagine on a single chip, you have a real computer with DMA. So you can transfer a huge amount of data coming from the other interface and move to another one. You have USB, you have E2S to have digital audio, digital sound, ADC, DAC, and so on. So a lot of devices, 52 pins to have IOs. So it's huge, okay? And it's a single microchip inside. The other components are just power regulator, capacitor, things that make the whole stuff stable and nothing else. That's so different than in comparison to our CPU in the computer, which requires a motherboard. Okay, you need more chips to make it work. So what's the difference, basically? In a microcontroller, we have single chip, no operating system. In the other side, we have a full operating system, and the basics is that you may have the need to deal with real time. So if you have the need of real-time communication, through real-time communication, either you go to real-time operating system, which are pretty hard to use, or you simply use an Arduino, let's say, or other similar components like a microcontroller where you have the full power and you run synchronous code. Well, not really synchronous because you also have interrupts, so you can deal with a certain amount of asynchronicity. The difference also is in terms of price because they are very cheap. Okay, in comparison to other, I mean, like $5, $7, you have these boards. It's something extremely cheap. And real-time processing, of course. Data acquisition on reboot is something that is another point. If you talk with the hardware guy, and you ask, I want to build a device who blinks on my tie, okay? And so you push the button, and you blink for 5 times. as a software guy, so we would solve the problem by looping in an infinite loop, sleep for some time, and then turning on and off the LEDs. So, I mean, it's pretty usual, while true and blah, blah, blah. And instead, the hardware guys say, oh, no, not at all. He goes to the main, so the boot time, when the power goes on, and put the LED to turn on, and then pause off, pause on, pause off, and so on. And then sleep. And there are basically two advantages. The first one is that every time the device, you push the button to turn the LED on and off, you have a reliability because you are booting. So we know that when we have problems on these PCs, we have to reboot, exit and enter, the Bill Gates rule, right? That is, we have to reboot. And that's basically what happens on hardware device. We just push the button when we boot. And the boot is lightning fast, so that we don't have problem in waiting that something happen. And the other advantage is that when you sleep, you consume just microamperes. There is no CPU running. You are really sleeping. So I created a device that it lasted like 3 years of battery. I forgot, and when I turn it on again, oh, wait, I'm here. It was yesterday. No, it's 3 years. Come on. So these are the points that you have to consider when you will try to make something at home or at your company that deals with interfacing with devices. So now we are on the Raspberry Pi. This is a microcomputer, let's say, which is $35, the official price list. Okay, it's very easy to buy. It has the micro SD, which is an advantage, but also a drawback, because of course you have the slowness of accessing this kind of hardware. Also, the entire bus inside the motherboard is based on USB, so it's not lightning fast. It's not like having, just to tell you, the power inside our cellular device is extremely higher. I mean, this is our super servers of 5 years ago. So we cannot compare. And also we know that there is a good difference with the prices. So you can imagine that the difference of power and price justify this. The good thing is that we can use .NET Core on those devices. And we can use the whole power. There is no restriction. It's not like Windows CE or Compact Framework or things like that. There are no limitations. And we will see in the example. And you have basically three options. If you want, you can deploy here the .NET Core SDK and write the software here, because this is a Linux distribution, the Raspbian one, that has also a desktop. So you can use using the keyboard. And inside this box, there is a monitor, an HDMI monitor, and you can use as it was your laptop. In many countries, it is used to teach to kids to use the computer. So it's extremely cheap, but it works. And the second option is to install the .NET Core runtime. And the .NET Core runtime means that basically you can just deploy your application, and you have the runtime that give you the possibility to just run the application without putting additional files, just not to have an application which is fat. Okay? But the third option is extremely interesting, because if you want, you just don't install anything. You take the plain Raspbian distribution and then Xcopy. So you just move using SSH the files that include everything, including also the .NET Core runtime, the CLR. So you have the so-called self-contained deployment. But there is more, and we will talk a bit later. And of course, with the .NET Core 3 that is coming, and then I am using in those demos, here I am using .NET Core 2.1, and here I'm using .NET Core 3, is C#8. So you can use all the goodness that comes with the newer version. I am using currently with .NET Core 3, the preview 5, by the way. I don't have demo for the remote debugging because it's so simple that it doesn't worth to spend even a minute on that. So if you want to see it, just join me at the discussion zone, because you just attach the debugger via SSH, and it works. And you have breakpoints, locals, and you can view variables and so on. So that's it. And if you want to get deeper, you have also the option to load with the native Linux debugger the SOS extension and make the crash dump analysis and so on, so you can go further. In order to get started, the first thing is going to the official website, and depending on the hardware that you have, you download the distribution that is ready. I suggest the default one, which is the Raspbian. It is derived from distribution from the Debian. And, but you cannot use the Raspberry Pi Zero at the moment. So Microsoft didn't say anything officially, but they let intend in some speeches during the build session that maybe there is support for the ARM v6 may come, and we will see in the future if it's true. The good part is that this is $35, the Zero is $10, so even cheaper and less powerful, of course. And with the .NET Core, I initially spent a lot of time in writing all the commands to install, to configure, to adjust a few things. And so I believe that this is annoying during a session talking about all the steps because you easily forgot all the things. So I decided to create a repository, which is GitHub Raffaele and Raspberry Pi, which contains all the tutorials, all the pages that I create as soon as the things goes on. There are many that already works, many other that I'm working on, so it's not yet complete for the .NET Core 3, but more pages are coming, that contains everything you need to start from scratch and install everything you need and goes on. So I don't want to spend time in showing you the setting up the device because it will take like 1 hour just for this. Useful tools. This is an important page. Since this is a Linux device, you have to talk with the device using SSH. And there are many clients that you can use. PuTTY is probably one of the most famous, but I will strongly recommend Bitwise. Bitwise is a good client. It also supports the SCP protocol, which allows you to just drag and drop the files from one side to the another. It's very easy to use, and you will see me using Bitwise during the session. Another tool that I created personally is deploy tool in order to have a kind of continuous deployment. So once you finish to compile on Windows, you can just, with an interactive console, push a button and deploy. So it takes care basically to bring the device, make the publishing happening, then copy everything on the device, and then adding the attribute for the execution for the executable so that you can execute the things on Linux. You know, there is no .exe in Linux. You have to add an attribute. So there are a few things, and this simplifies the task. So you're free to use it. There is a branch that contains the latest thing for .NET Core 3, by the way. So what are all these pins that we have here? What they contain? There are several different things. So first of all, the pins, the numbering is the one that you can see here, 1, 2, 3, 4. This is the hardware way to name the pins. So then there is the BCM and WPI that are different. Why? What happens here? Basically, this means that this is the chipset. BCM is Broadcom. And WPI is a wiring pi, which is a very popular library in C++ that provide an basic interface, and it's widely used by the Python community. Okay, but the new library from Microsoft uses the BCM convention. So it's just a match. You have just to match the numbering. It's not a big deal. So if you want to have this pin, you just take 3 and you are okay. And you have the power, you have the camera, which is interfaces here. I 3D printed a few parts in order to make it cooler. And the HDMI, that you have also the monitor in order to work locally. You can connect a keyboard on the USB, and of course the Ethernet that is important to have. I prefer having wired connection because I'm old school, you know, just joking. And you know, there are many different things. Basically, you have three classes that the most important IOs that you can use. The plain pins, so the GPIO, which are general purpose IO, and then the port that is called the E2C, the inter-SIP communication. So it's a standard created by Philips many, many years ago, and was created to avoid parallel communication. And this means that with a few wires, you can communicate between the chips. And then you have also the PWM, which is a pulse width modulation that allows you to drive servo motors, the one that you have on the toys and you can use with a car that you may have seen. The new system device namespace is part of a library that is going to be released probably with .NET Core 3. This is my guess. It contains a whole new set of things that are very useful to interface not only with the Raspberry Pi but also other devices. And they provided the way to manage the GPIO, to see a PWM, as I said, but also a number of bindings, which means real devices. For example, if you have to talk with a servo motors, you already have the class for the servo motors, which in turns use the abstraction of PWM. And if you have to talk with the temperature sensor, okay, it's already there. There is a device that uses the GPIO and in turns returns the temperature and the humidity and so on. So there is a very long list of this, but I will show also a custom device that is extremely interesting. And this library is published on .NET IoT. So let's start. If you want to create a console application, by the way, the console application is super important. And if you want to make the right choice, you have to start with ASP.NET template and then choose the worker template in 2019. Because this provides you basically a console, but with the addition of dependency injection, logging, and configuration, which is extremely important to have in any application, not only in a full-featured ASP.NET application. So this is my suggestion. And once you have this, you can work, of course, with net standard libraries. There are three that deals with device. So beyond the one that I already told you about the .NET IoT, there is the Uno Square Raspberry I.O. and the Pi I.O. by Peter Markku. This guy is a Microsoft guy. So my guess is that now the Pi I.O. has been merged with the first one. But if you want to try, it's there. In the case you use something that is very specific to the Raspberry, you may want, or the Linux ARM in general, you may want to add this specification, the runtime identifier, inside the CS Proj. This is needed at the moment, maybe not more in the future, for the first one, so for the .NET IoT. So I prefer to leave a note here in the slide so that you can remember. Okay, so let's see what happens. Basically, we have, sorry for this, okay. You see, I'm working here. And I can go here and say, let's see if I have already something. No, okay. .NET new console, minus output, hello. And when you work with the SDK locally, it is very slow because the SD card is slow. So it's not something that you may hope to solve easily. There are many things. It's an SDK. I mean, it's not something that is easy to solve. So you have to be patient. And you see there are many options here. And we can .NET run, we can do many other things. But I want just to take the publish. And you see, .NET publish, what it means, this stuff, is -c release. Well, this means basically that you want to build a release version. I have to ask the build to create the ARM compiler, the ARM version, because I am on an ARM device, and I want to specify the self-contained. If it's false, it will require the .NET runtime. Otherwise, it is totally, you can totally get rid of it. So you can just specify self-contained equal true. But you can go further, and you say, okay, I want to publish ready to run equal true. What it means? This is very nice. You can compile directly in assembly mode. You can create ARM assembly code. That means that you don't have to JIT the things the first time. And this is also valid on Windows, by the way. So if you have an application like WPF on .NET Core 3, or if you have a server application, an ASP.NET application, you can start trying it because it works pretty nicely. And you end up having the first impact on the first load, on the first boot. But we can also get further, and we say, okay, I want also a single file. So that means basically that instead of having a whole set of large number of files, which is very long, and have a long list of dependencies, because you have ASP.NET, you have all the CLR stuff, the debugging stuff, and so on, you have just one exe and nothing else. Of course, it's fat. It's about like 60 megs, but it's one file. And it's extremely interesting. While this guy is working, I want to show you that the same thing can work with Ubuntu. And it's a very nice thing that you can, let's do, no, it doesn't work, okay. We can, since we are on Linux, this entire command line can work also on the WSL. Of course, I have to create the project first, but I wanted to save the command line. And there is the ability, this published ready to run means that if you create the project and then you go inside the project itself, you can do the same thing targeting Linux ARM. So it's a cross-compilation, but you have to stay inside the same operating system. So this doesn't work if you run from the command prompt in Windows, but it works just because you have the ability to run it on the device. Okay, .NET, publish, blah, blah, blah. Optimize and assembly is not supported for the target. I will show you later on the WSL, you know, the machine. Okay. Should been release netcon 3. Okay, it's a deep path, and we have this here. Okay, looks like something gets wrong with the single file. But we are almost there. Single file equals true. That's fun because I tested this and it worked, but maybe, yeah, it's self-contained, but we can repeat. This is pretty new because it has been released just for preview 5. So I had a few times to investigate all the thing, but it definitely. Okay, here we are. You gotcha. By the way, the same thing is possible on WSL. So you can do it here. And probably the problem is exactly the same, but we will, oh, it's false, and this is the reason why. Okay. So we discovered the reason. Okay. Of course, I cannot run this inside WSL because WSL is running on x64. I created the binary for ARM. So at this point, if I use WSL, I have to copy the file on the device. The advantage between the two is that I have an increased performance on working on the WSL. So the compile time for a larger application, this is just a simple console. But if you have a larger application, of course, you may want to do it on WSL instead of the device because it will take a lot of time. So there is an advantage in working in Bash inside Windows. And you know that WSL is going to have a major upgrade starting from this summer. So it's extremely interesting. So this is something that is super valuable, is super important for any application, but for sure is very important also for us on the device, because the device is so constrained from the resources perspective. You have a small amount of RAM, and the disk is quite slow, so you have to take care of this. So the continuous deployment is something that you may need, because when you deal with an external operating system and you don't have something interactive, it's annoying. Every time you have to copy the file over a CSP, and then you have to give the attribute and remove the old files and so on. So it's annoying. If you want to take a look, this is my deploy tool. The new version is on a different branch. I still did not release the very latest. So if you want to try it, then let me know what you think. We want to go deeper. So we start a journey with a brand new application that deals with the camera, which is a very nice device. I mean, it's something that turned me on. I mean, what's new? I can have a small camera here. What can I do with that? And so one of the good things that we have inside the motherboard of the Raspberry Pi is that there is a hardware encoder. So there is a hardware H264 encoder. So we basically don't have to compress the image because it's provided by the hardware. And this is very good because it doesn't consume any CPU. So when I first saw this, I said, I want to stream this stuff to the web browser so that I can see remotely what happens. And the first thing is that it was quite annoying to go to the specification of the camera and understand how can I interface with the local driver. I mean, it was then a bulb turned on in my mind, and I said, come on, we are on Linux. We have pipelines. And you have the ability to use the standard input, the standard output that is very cheap. It's super light on Linux. So why we can't just run the RaspiVid? So I don't know the pronunciation correctly, but the RaspiVid is a utility that comes with Raspberry that talks with the camera. And they can redirect the whole stream on the standard output, as a binary, of course. Okay? And so I said, we can just run the process and take the standard output from the default one, and using, in my application, the pipelines, the new stuff of ASP.NET, to optimize and the throughput and then minimize the number of copies of the buffers, which are pretty big. And so the other point was, when I tried first, I had the problem that there is this Broadway player in JavaScript, default player, which runs on plain HTML5, is a good player, but has a little defect. It cannot identify the frames. So you have to provide one frame at a time. Otherwise, it's not able to understand what is coming out. It can play an entire file, because when you start to play the file, you start from the beginning. But if you join a stream later on, he just see a blob and screw up. So I had to create a frame splitter that identify the frames inside the stream, and I had to split it on. And once I split the frames, I take one at a time, and I send to the browser using WebSockets. Does it make sense? Okay? So the frame splitter is something, oops. The frame splitter is something very interesting. Because basically, we have this class. Don't want to dig too much in the details, but this is the marker, the separator from the frames. It's sufficient to have this there is a guarantee that we can split the frames like this. I have a circular buffer that I manage by myself. And then, beyond resizing and so on, I have this continuous read that takes the pipe reader and invokes a delegate, giving the piece of buffer that defines a single frame, the numbering of the frames, and then I return a task of bool in order to be able to stop the streaming. And so I read from the pipeline here, and I iterate over segments. I find the sequence, and once I get that, I get the frame, and then I simply give this frame on the delegate. And so someone else will do the dirty job, okay? So that's it. Of course, there is an accumulate that is going to copy the part of the memory inside the circular buffer. This is needed, otherwise the stream coming from the other process is going to be overwritten very quickly, and you may lose it before processing it. So this is the copy in this case is needed, but I don't need to allocate more memory because I manage only a ring buffer, so that's it. And once I have done that, I am okay. So I have the stream in my process. So you may wonder also, how can I take the pipe from there? And there is this process executor that is very simple, because you know that standard output exit with the stream, and there is this nice extension method from Microsoft that basically make a copy which is optimized in order to transform a stream into a pipe. And so I use the pipe writer to publish the things inside the pipe, and from the other side you have already seen that I consume the bytes that are coming from. And that's the first point. At this point, I have an H.264 buffer that is well splitted, and I stream it on the video. We will see in a moment the demo, but I want to do more. I mean, it's not that wonderful. So I also understood from the frames that you may know that how the compression video works. Like it's similar in MJPEG, for example, where you have a full frame that define entirely an image, and then you have several frames which are the difference from the full one. So the full frame is the one that is already self-described, and the other are only chunks that defines the difference from the full one. These are important because I had an idea. I really wanted to decode few images of the stream, but not them all, because otherwise it takes a lot of CPU to process this thing. And so I really wanted to do a different thing. So the first step was, what about adding 2 servo motors that you can see here? I can move it by my hand. You see there are 2 motors. Okay? I want to control them from the Raspberry Pi so that I can move the camera. And this is quite interesting because if you go to this, you can see that I am using the device GPIO and PWM library. Okay, there is of course some code from me, like a concurrent queue and so on, because the current PWM implementation has a small bug that will be fixed. But basically, I want to move the servo motor not instantaneously. If you have played with the toys, you know that as you turn the steering wheel, it's lightning fast. Oh, you cannot control the camera this way, otherwise people will have nausea. It's impossible. You have to move the camera smoothly. Okay, so I had to make additional work. But basically, the idea that once it gets fixed, you have a servo motor definition to say what are the specifications of the servo motor. You may find these numbers on the website of the servo motors. And then I defined 2 servo motors. And once I've done that, I created a background thread that instead of moving immediately to a certain angle, it's simply at a cadence, move 1 degree at a time in order to get slower and slower. Take care, come on. We don't want to be super accelerated. And so I move. At the beginning, when I turn it on, is 90 degrees. And then there are several move and so on that deals with the angles. So this is just math in order to deal with the angles and nothing more. So that's it. That's another interesting part. So of course, I tested all of these parts separately with a separate console so that I can move each axis, check it if it's run and so on. So it's a long work that you have to do in order to improve. And then I said, okay, I want to do something more. I want to control that. How can I move the camera now? And I want to introduce a gesture controller, which is pretty nice, because if we go to this, and we have this gesture client, I will have to show using the camera, my camera here, that I can control, you see? Flick east to west, west to east, but I am not touching the controller. I'm just moving my hand over. And the interference of my hand over this plate, you see, this one, is everything I need. By the way, I soldered by myself initially this microchip because I have a little hardware lab. I have the Microsoft 3D and so on, and I created a similar device, but this is neater. And you saw when you comes to the immigration in Russia, I don't want to have too many wires, so I prefer to buy a new one because it looks like a finished product. Mine is a bunch of wires. It can be dangerous. And so you see I have the position of my hand, the 3D coordinates, and I also have the touch controller. I can even touch if you want. So there are a few things that are coming here. And I created this new device because it didn't exist before on the GPIO library. And I created the so-called gesture sharp. And this gesture sharp is made with several commands, and the interface is E2C. So basically, each command has a different number, and then I have to the American says bit banging, so managing the bits, turning a single bit inside the byte on and off, and because this is the specification, so I started from the specification of the device. And this flick class manages this fixed address on the E2C bus, and then you have to control other additional GPIO pins in order to control the thing. The good part is that the most complex was bit banging. I mean, understanding if the protocol was right. But the class, the system devices class was enough to do all the job. So I have primitives that are like reading and writing, and as you can see here, and that's all you have to do. I mean, there is nothing more. And again, this is using span of t, and it means that you don't have to copy buffers again and again. So it's extremely optimized and very well done, and you can manage this. So the idea was to go in the first version of the application. And this is an ASP.NET application which deals with the streaming of the video. And so I can connect with my browser. Okay. Okay, you see my hand? And I can control the camera this way, you see? And I can go up and up and up. And if I touch at the center, I should go back to the original position. Okay? Almost. Okay. Ciao. And so on. Okay, these are very cheap servos. I mean, like $7 for 10 of them. So it's really super cheap. And they're analogic. There are digital ones that are far better and doesn't have those shaking movements. So don't bother with the movements that are not very good. And it looks pretty nice. And we managed to have this servo, the gesture controller. We have the servos. We have the camera. We are streaming. I mean, I decided to go low resolution just because it fits better with everything, but you can raise the resolution as well. And we have the nice logging system and so on. Frankly, it's a good thing that we have to do. But it's not enough. I mean, we want to go further, of course. And so I decided to do additional thing. So the first thing was I want to start again from the frame splitter, and I already told you that we have the full frames that are very important because they self-describe themselves, and so I wanted to decode them. And so I compiled the H.264 decoder inside of Ffmpeg. And I am using the Ffmpeg library in order to decode this thing. And I really wanted to add the facial recognition so that I can analyze the image that has been decoded, giving them to OpenCV, which have very smart algorithms. By the way, I first tried the very latest fancy new wave of recognizing objects that works pretty well. It's called YOLO3, which is an artificial intelligence extremely sophisticated. But on those kind of devices that are not, they have GPU, but it's not powerful enough to make this computation. It takes about 2 seconds for each image, which is pretty cool because we are talking about a $35 device. And it works nicely if you have to analyze only static images. But on video streaming, it's not that good. I mean, I want to have better performance. So I had to choose a more rough way to analyze the signal. And so the idea was I want to take a basic algorithm, recognize the faces, and then extract the coordinates from the face. And once I extract the coordinates, I create a JSON file that I send inside the same WebSocket. If you don't know, the WebSocket has implicitly 2 different channels, the binary one and the textual one. But it's a single communication channel. It's a single TCP connection. Okay? So basically, in the browser, I don't want to touch the player, which is an astonishing work, but I don't want to mess with it. I intercept the textual messages, and I can do something on the client side with the coordinates of the face that had been recognized. So basically, I wanted to go further, and I will show this step, which is really great. And I will show the result first. Let me restart it, because it already recognized you. You are too many people inside the room. Oh. Okay, and here we are. So I have to move a little bit, and I want to introduce myself, mini-me. I 3D printed myself. You see E smiling. It's mini-me, which is pretty awesome, because when I was doing the demos in my house, at a certain point I was pointing the camera to me, and the camera turned back, and I had one mini-me on my desk, and I said, oh my God, it's recognizing his face, not my face. What is happening here? And it was quite astonishing. So, and you see, it takes a while. You have to be a bit of movement, of course, but it's tracking. I mean, it works pretty nicely, okay? Let's hope it doesn't see the video. Then I want to, what kind of application I can do for this? And I am passionate of action movies, you know? So it's really cool, and said, what about this one? Hasta la vista, baby. So it was fun. You can see it can recognize pretty nicely. So let's instead see, you can see that it moves pretty well. It's saturated. It's tired. It's a sniper that is saturated. Let's redraw it. By the way, if you look at the history, you can see elapsed 260 and so on. So these are milliseconds of the time that takes OpenCV to recognize the face during the frame processing, which is pretty good, 260 milliseconds instead of 60. Oh, okay, it worked. And so what's the code for this? And we can go deeper then if you want. So basically, the good part is that I designed as a startups in the startup the service for ASP.NET, and everything is a service. So, for example, I have two different trackers. This is YOLO thread, which is very slow, of course. And the other tracker is this face tracker, but I can add and remove them as services inside ASP.NET, which is pretty handy because you have the dependency injection, and you can do it by configuration and change the way the application behaves depending on your configuration. You have the access manager as well, so the one that controls the servo motors, okay? And then I have different capturing services. I also tried you may know that OpenCV also manage the camera by themselves. They can drive directly the driver of the Raspberry Pi. Unfortunately, and it is well documented on GitHub, they have a leak. So it rapidly goes out of memory because OpenCV has an open bug that has not been fixed yet. So the trick of using a standard output as a separate process, it was absolutely the best choice. So minimize the amount of code that you have to write, and it doesn't have leaks, which is pretty good. the other parts, let's take, for example, the video service. And you may know that when you are in a service at the beginning, you can declare what you want in the constructor from the dependency injection, and you have logger factory, video capturing service, so that I can hook the data coming in. The tracker, that is the face tracker, the access manager, and the application lifetime, because of course when I press Ctrl-C, I want everything to be disposed correctly, and I want to shut down the application, and this is the way it happens. And of course, I have separate thread to maintain the face recognition happen, the decoding happens. There are many concurrent operations. And since they are on long-running thread, I really wanted to dedicate a single thread from them instead of using tasks for obvious reason. So apart from the main, this is the conversation from WebSocket, for example, but it's very simple. The processing the frames is something that happens this way. So I have the frame splitter that we have seen before. During the continuous read, this is the asynchronous delegate that is called for every frame. I can identify, thanks to this magic number, the kind of frame that is coming. And if is one of this, I have to give the frame to Ffmpeg in order to be decoded, because it's a full frame, and the decoder needs to have this information to correctly decode the frame. So this is a feed frame which put in a queue a full frame to be decoded. And as soon as Ffmpeg is ready to decode a new one, it empties the queue and takes only the very last, because I don't want to decode the things in the past, of course, otherwise the dot will be outside the boundaries. It doesn't make sense. And at the same time, regardless the magic number, I want to send the frame in the binary WebSocket channel so that the web browser receives them all. And so I have the continuous streaming for the browsers. And of course, there is a lot of other code. I had different strategies. Ffmpeg is not super easy to use. There are many different possibilities that you may choose. And so I picked this one. So before closing the session, I want to show another totally different demos, because we have another interesting thing. And we'll, this is the algorithm, by the way, that I use it to understand how to move the axis. So I think it twice. I said, when I have to move the camera, I cannot know how deep is the face. So I cannot move at a certain angle or an amount of pixels. So I split the images in several pieces. And every time I see that my face is inside of a certain area, I move of a certain angle. And recursively, I go smaller and smaller so that it's even more accurate over the time. And every 260 milliseconds, I can move again in order to get closer and to adjust the image. When I am under like 1 or 2 degrees, I cannot stop moving because it's dead. It's okay. So on this other side, so this other device, totally different demo, just before we finish in 2 minutes, is a demo that it's reading an RFID with this new device. And you know what? This is an ASP.NET application and is running on what? Is running on a Docker container. Yes. You can run Docker container there. And if I manage to move the device here, you see granted, and you see running the lookup for my key number inside the database. And here we have a denied access. You see the red light, and again, the green light. And this is super cool, because you may think that Docker containers are expensive. They are not. And they can even run on this device. And you can deploy a container here. So the container story is super important. You can run even the container in a privileged mode in order to have more access if you need to do something special inside the operating system. In my case, since I am a security guy, I prefer to create two different processes, one that cares of the acquisition of the data and can run regardless of the rest. And when, from time to time, I have a full-featured ASP.NET application that can have all the goodies that you want. So we can go to the logs and see, OK, this is the access I just made on the device. And you see that they are growing in number and on and on. Okay, so this is extremely nice to see. And if you have questions, please reach me later that I can dig in and so on. Just for going to close, I will let you this suggestion, but I will add these details on my Raspberry Pi repository. The Docker on the Raspberry Pi is better to see on a demo instead of the slide. So this is the pointer. And as a takeaway, go to the material that I am writing. I continue to update and start using .NET Core on Linux. I'm happy to be there. Sorry if I had to run a little bit, but I hope you enjoyed the demos. And thank you very much for your participation.